I do the enrich section for test 3? I forgot to do that.
You can do that, yeah. We could even do that today. Hi!
Okay, I'll do that tomorrow.
You need a workbook, right? Yes. I don't know, but I always layer because I never know whether it's going to be too hot or too cold. So I always like to have a t-shirt and then something to put over top. Because it's really hard to tell what you're going to need to wear. All right. We are, let's see, we don't want Science 9, we want Chem 11. There we go. Chem 11, nomenclature, there we are, okay. This is page 87. All right, page 87. What's this? This is a crystal lattice, an ionic crystal lattice. What state is it? Solid. So when we have a hydrate, what we have is a salt. And what is a salt? A salt is an ionic compound, and it is a solid. What does the word hydrate make you think of? Water, right? Now, what if I was to take a couple of these little binder clips, and the reason I've chosen them is because you can almost imagine that they are water, because you've got the O and then the two little H's, yes? You've got the O and then the two little H's, H2O, H2O. Do you see how there's space? In here, there's like empty, I can fit my whole hand in there, right? Water is a little teeny tiny molecule. It can actually, for some ionic compounds, slot itself right inside those spaces. Is this still a solid? Yes. I mean, look at it. Does it look like it's a liquid? Is it flowing? No. This is still a solid, but it has water embedded inside the crystal lattice structure. Okay? So it's an ionic compound with water attached. So actually this should say a hydrate. There's a typo in here. This is terrible. Okay, a hydrate is a salt with water molecules embedded in the solid crystal lattice. And a hydrated salt is just another word for a hydrate. But an anhydrous salt is a salt, and this is where I made the boo-boo. It should say a salt without water molecules embedded. An, the prefix an, usually means something along the lines of not. And we're actually going to do a lab. I know it's been a while. It's been a long time. We're going to do a lab where we have a hydrate. We have a hydrate, and we want to figure out how much water there is inside the hydrate. So what we're going to do is we're going to light a Bunsen burner, and the flame will heat the ionic compound. What happens to things when they are heated? What do they start to do? They start boogieing faster. Okay, so here is my ionic crystal lattice with the waters embedded in it. It is a hydrated salt. Okay, it's moving faster and faster now. What kind of bonds are in between the sodium and the chlorine? Sodium and the chloride. Those are ionic bonds between ions. What kind of bonds do you think are between the water and the ions surrounding it? Intermolecular forces. So which ones are strong and which ones are weak? The intermolecular forces are weak. The ionic bonds are strong. So watch what happens as this thing starts to, as Nathan said, boogie faster. Gets faster, gets faster, gets faster, and all of a sudden, the gas, the water, and if you weren't paying attention, you missed it. Too bad. We had the water came out as a gas. So when you do this, you'll actually see steam coming off of the solid as the water is driven out. And now we have an anhydrous salt that does no longer have any water inside it. So what we have done is we have dehydrated that salt. Okay? So if we look at this thing, here's like our little picture of what that might look like. Okay? This is just one little cell. This is representing one little cube of the ionic crystal lattice, but it's only in 2 dimensions because I can't draw 3 dimensions. Okay? And you'll notice that within the crystal lattice, this is our crystal lattice. Within there, the water is in the spaces in the crystal lattice. We heat it up, and the water, comes out as a gas. And if we were to do this, the formula for the hydrate, and in fact, I've done it wrong here. We have CaSO4 dot 2 H2O. That's how we show that the water is loosely bound. That's a dot, not a decimal. It's not a times sign. Okay, so that's not times, it means it's a dot. And it means is loosely attached. So we have two waters loosely attached to the calcium sulfate. Put a star there because I've got typos I need to fix. So many people think that a salt with water in it must be a liquid, but it's not true, okay? It is a solid. It's got some water in it, but it is a solid. And when we heat it, what breaks? The IMFs break and the water comes out, but the ionic bonds, do they break? No, they stay intact, okay? Now, here's the part you need to know for this unit. The other part you'll need to know for our next unit, which is the mole, okay? Yeah, math, we're back to math next unit. Woohoo! Naming hydrates, we are going to name the anhydrous salt. You already know how to do this bit. This is just naming ionic compounds, right? So you've been doing that already. So there's nothing new. If you can name ionic compounds, you can name a hydrate. The only thing that's different is you have to add the word hydrate to the name. And not hydride, hydrate. Okay? And not only the word hydrate, but we also need to use the appropriate prefix, which just so happen to be the exact same prefixes that you use with covalent compounds. So, not too complicated. If you have one water attached, that's going to be monohydrate. If you have two waters attached, dihydrate. 6 waters attached, hexahydrate. Now, watch out for the dot. Some people get very excited about the dot. They see it here in the formula. Remember, this is the formula. And yes, the formula needs the dot. That means there is one water loosely attached. So this would be a monohydrate. Mono, because there's one water. NH4 we know is ammonium. C2O4, you might have to look that one up. It is oxalate. Watch out, a lot of people see C2O4 and they go with Cr2O4, which is a different ion altogether. Just be careful, right? C2O4, that's oxalate, so we name it ammonium oxalate. And then we write, because there's one water, monohydrate. But you know what there is not? There's no dot in the name. The dot is only in the formula, okay? No dot in the name, only in the formula. So again, here we go. Let's take a look at this one. Oh, look, that's calcium, so we name it calcium. It's attached to nitrogen. What do we do to the name of nitrogen? We change it to nitride. So we have calcium nitride. It's attached to 2 waters. So what do we add to the name calcium nitride? Dihydrate. Yeah, so you'll just be naming your ionic compounds. Another one here, we've got K. That's potassium, CH3COO, acetate, potassium acetate. We have 3 waters, so it will be trihydrate. And don't forget, iron is in the gray zone. If it's in the gray zone, what does it need? It needs the charge, which is the Roman numeral. So we would have to say I have one PO4. Remember, we don't have 4 PO4s, we just have one. One PO4, it has a 3 minus charge. So what does the charge of that one iron have to be? It has to be 3 plus, so that's going to be iron 3. Phosphate. And then, of course, we need to add on to our name tetra for 4 hydrate. So here we are, we have iron 3 phosphate tetrahydrate. So that's how we name them. Writing the formula. It's just like writing the formula for any ionic compound. You just have to add some waters on the end after a dot. So you would say, okay, I have copper sulfate. Cu is 2 plus. SO4 is 2 minus. So they already balance out. So I just have Cu, SO4. And then I have pentahydrate. So that means I have 5 waters. And don't forget, in this case, it's the formula, so you do draw the dot. Do you know why I have barium hydroxide as an example? There's a really common mistake people do when they have barium hydroxide. They forget to show the brackets. I see this very often, BaOH2, okay? You absolutely need to have the brackets, otherwise you only have 2 of the hydrogen, not 2 of the oxygen as well. And this is heptahydrate, so we would have 7 heptahydrate. Okay, and then there's practice on these. How are you guys feeling about acids? Does anyone want a little review on acids? Yes? You can just ignore me if you don't want to hear a review on acids. I'm just going to do a very quick little acid review. So the 3 rules around acids involve knowing which type of ion goes with which type of name for the acid, okay? There's 3 types of ions. There's the ide ions, there's 8 ions, and there are ite ions. So in our little system that helps us remember what to do with each one, my ride has hydraulics, which is I think probably the weakest of the one, but I can't think of anything better, so I'm going to go with that. So my ride has hydraulics. So if I had HCl, for example, Cl is chloride Then this would be named, we would take away the "ide," right? We would say, let's get rid of that little "ide" there, just use the chlor. And we would have hydro, and then we put the chlor in the middle, chlor, ic, and then we always put the word acid on the end, hydrochloric acid. Our second type of ion is the ate ion. I ate something icky. So when you have an ate ion, it's going to become an ic acid without the hydro. There's no hydro this time, okay? So if I had HNO3, NO3 is nitrate. So there's our 8. And again, I'm going to take that little bit off the end. And now I'm going to name it. It is nitric acid. So all the acids, most of the acids end in ic. They're either hydro something ic or they're just plain ic. There's one type that's not ic, and that's the ones that where you have an ite ion. My Sprite is delicious. And this is an OUS for us. My Sprite is delicious. So let's say I had H3, PO3. PO3 is phosphite. So I'm going to take away the ite and I'm left with the phosphor. And this one is going to be, I didn't choose a good one as the example. This one is going to be phosphorus acid. The reason I said I didn't pick an awesome example is because this is one of the exceptions where you actually add an extra syllable. Most of the time we don't. 2 elements, we add extra syllables when we name the acids. So maybe a better example for this one would have been H2, or sorry, what's that? Phosphorus and sulfur are the 2 examples. If we wanted a sort of more stereotypical one like this, I could have said HBrO2. BrO2 is bromite. So when I name the acid, it would become brome acid. Okay, so we just replace the ite with an S. Now, as I said, there's two elements where we have to add an extra syllable. Sulfur and phosphorus. So if we have H2S, so if I have sulfide, I can say, okay, my ride has hydraulic, so that's going to be a hydroic acid. So it's going to be, normally we would think sulfic acid, but that is not correct. It's actually going to have the extra syllable, so not just sulfic, but it's going to be sulfuric acid. And oops, I forgot. It's not just sulfuric, it is, what did I forget? I forgot the hydro. Okay, because this is just this is an ide, so it needs that hydro. So this is hydrosulfuric acid. H3PO4. PO4 is phosphate. I ate something icky. So we're going to take that ate and take it away and replace it with an ick, but we're not just going to have phosphate because P is one of the ones that needs an extra syllable. So it's going to be phosphoric acid. The nice thing about the extra syllable, if you're like, I don't know what to put in there, it's always either a UR or an OR. And if you're like, I don't know which one is which, well, the UR goes with the sulf, which has a U, and the OR goes with the phos, which has an O. Okay? Does that feel like enough of a review for now? Okay. So if you guys want to, oh, and I've put up, if you haven't finished up to quiz 10, I've put up here what you have not yet done. So if you're missing anything, try to get caught up on those today. If you don't finish them all today, I would like you to come here, you must come here during Flex tomorrow to get caught up, or if you need some help or something like that. It doesn't mean like if you've been away or whatever that you have to finish them all tomorrow, but I would like to see you so we can get you as caught up as possible. Okay? Well, what's wrong with me? You are first because it's like every time with you, right? I misplace your quiz and it's always your quiz and you've always done them.